Hello class, in this lesson I will go over arcs and chords. We're going to cover a few different theorems. The first one, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So first of all, what are chords? So chords are segments that connect 2 points on the circumference. So here I have an example of two different chords. So the segment DC, the segment C prime, D prime, those two would be a chord, or if I wanted to connect D to B, then that would be another chord. So a segment that connects 2 points on the circumference. Now, what the theorem is telling us is that if we have two chords that are congruent, which is what these two are, C, D, and C prime, D prime, they are congruent, and I'll go ahead and show you their lengths. Okay, so these two chords, CD and C prime, D prime, they're both congruent. They have the same measurement. So what the theorem is telling us is that if those two chords are congruent, if chord CD is congruent to chord C prime, D prime, then their corresponding arcs are congruent too. So the arc for CD, it would be the arc CD. So arc CD should be then congruent to arc C prime to D prime. So notice that the endpoints of a chord are the endpoints of its arc. So let's go ahead and demonstrate that this is true. So here's arc C prime, D prime. Okay, that's corresponding with chord C prime, D prime. Now that should be exactly the same as the chord from C to D. So what I'm going to do is move that chord along the circumference, and it should overlap arc CD. And it does. Okay, that's what this theorem says. As long as the two chords are congruent, then you should expect to have congruent arcs. So here's an example about theorem 9-1. We have an equilateral triangle inscribed in a circle. Inscribed means that the shape has its vertices as points on the circumference. So just like we have this triangle, we could have a square or a rectangle. Now we need to figure out the measure of arc ABC. So we're being asked for the arc from A through B and stops at C. So that's going to be a major arc. So we're looking for the measure of arc ABC, and remember that the answer has to be in degrees. Okay. Now, because this is an equilateral triangle, we know that all of the sides are congruent to each other. So the first theorem says that if we have congruent chords, then that means that their corresponding arcs should also be congruent. So that means that this arc here must be congruent to this one, must be congruent to that one too. Now, because we have a total basically of 3 arcs, meaning we have the measure of arc AB plus the measure of arc BC plus the measure of arc CA. Okay, so AB, then BC, and CA, then that's entire circle. So that's 360 degrees. So because they're all the same, that must mean that, if we just say that this arc is X, then the measure of arc BC should be X also, and the measure of CA should be X as well. So 360 degrees. So that means that 3x should be equal to 360, which means that x should be 120, meaning that each one of those arcs has a measure of 120 degrees. So this is 120, this is 120, don't forget the degrees, and this is also 120. So that means that the measure of arc from A that goes through B and ends at C is 120 plus 120, 240 degrees. This is the second theorem. In a circle, if a diameter or a radius is perpendicular to a chord, then it bisects the chord in its arc. So let's go ahead and use the circle that we have over here, circle A, to go ahead and point out what this means. So a diameter. So in this case, we have this segment EF. So we have that if the segment EF is perpendicular to a chord, in this case, we're going to say that it is perpendicular to the chord CD. So let's go ahead and show that they're going to be perpendicular. So when that is the case, then we're going to be able to conclude that the diameter will bisect CD. So we're going to end up with CB and BD being congruent. So segment CB will be congruent to segment BD, and also the corresponding arcs. So arc EC and arc ED will be congruent. So not CD, arc CE is congruent to arc ED. Now we can go ahead and show why that is true. So given that we have a right triangle here, if I were to connect A to D, that creates a radius. So with that, I create a right triangle. So if I were to connect A to C over here, then that would also be a radius. So all the radii happen to be congruent to each other. Now I also know that AB is going to be the same for both right triangles. So I have two sides that are congruent. And if I were to use the Pythagorean theorem, because I already have that the hypotenuse is the same, one of the legs is the same, I'll be able to conclude that the second leg is also the same. So by side, I'll be able to show that these two triangles that are formed will be congruent to each other. So by corresponding parts, that must mean that BD will be congruent to BC. Okay, so that would be one way to show a proof of this theorem. In circle O, the radius is 13 inches and segment OB is perpendicular to CD. So we have a right triangle there. Also, CD is 24 inches. Determine each measure. So let's go ahead and make substitutions for everything that we know. So radius is 13. So that means that OC being a radius, that should be 13 inches. Given that CD is 24, so from here all the way over to here, that's going to be 24. Now, because OB is a radius and CD is a chord, and they happen to be perpendicular, we can use the theorem that says that the chord will be bisected. So that means that CX will be the same as XD. We already know what the whole thing is, 24, so that means that each of those segments should be 12. And that's going to be the first one. The length of CX, that's going to be 12 inches. What is the length of segment OB? OB, that happens to be a segment from the center to a point in the circumference, so this one is a radius. So that means that the measure is 13 inches. OC, that's also a radius, so that is 13 inches. If the measure of arc CD is 134, find the measure of arc CB. Okay, so we're going to apply the same theorem as the one we applied to find that CD is bisected. So remember that the theorem says that if the diameter or radius bisects a chord, then it bisects the chord and its arc. So given that arc CD is 134, that means that each of those arcs should measure half. So this is going to be 67. Now we are looking at measures. So this is going to be degrees. So degrees, okay, it's not inches. Okay, anytime you measure the arc, that's in degrees. If we were looking for the length, then that would be some sort of unit such as inches or centimeters or things like that. OX is this part here, and that is part of a right triangle. Okay, so I have the right triangle where the hypotenuse is going to be 13, one of the legs is 12, and this is basically OX. So I can go ahead and apply the Pythagorean theorem that says that the hypotenuse square is going to be equal to 12 square plus OX square. So 169 is equal to 144 plus the length of OX square. So subtracting 144, I'll get 25. So taking the square root, I get that the length of OX should be 5 inches. The length of XB. Well, XB is part of OB. So I know that the length of OB is equal to the length of OX plus the length of XB. I already know that OB is 13 inches. I just found out that OX is 5 inches. So this allows me to go ahead and say that XB is going to be equal to 8 inches. And the last theorem. So we have that in a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Equidistant means that they are the same distance away. So here's what we have here. We're looking at the chord AC and DF being the same distance from the center. That's why both of them have a length of 10. Okay, so they are congruent. Now, the other thing about distance is that because we're looking at the distance from the center to this chord, we're looking at a perpendicular segment. So that means that there's a 90-degree angle here, and also for the distance between G and the chord AC, then that has to be a perpendicular segment to the chord. Okay, so don't forget those two things. We have congruent segments, but they're also perpendicular, so there is a 90-degree angle. So this statement here that the chords AC and DF are equidistant, then that pretty much tells you a couple things, that FD is perpendicular to GE, and also it tells you that the segment GB is perpendicular to the segment AC. If the radius of circle G is 26, then go ahead and find AC and DE. So we have to figure out from here to here, and we have to figure out this piece over here. Now, the first thing that I'm going to point out here is that we have a segment that's perpendicular to a chord. Okay, and that segment is part of a radius. So that means that we can apply the previous theorem that says that as long as you have a segment, be it a radius or a diameter, that's perpendicular to a chord, then it will bisect the chord. And because AC and FD are congruent to each other, then that means that these two segments will also be equal to each other. So that means that as long as I find one of these, then they'll be the same for FE and ED. So let's go ahead and figure out how we're going to find one of those segments. So we have the radius is 26. So that means that AG is 26. So this means that the hypotenuse of this triangle over here is 26. I have one of the legs, which is 10. So this way I'll be able to figure out what is AB. Okay, so I'll just go ahead and redraw the triangle over here where the hypotenuse, again the side opposite to the 90-degree angle, that would be 26. And then actually let me just go ahead and label the points, the vertices over here. So AB, I don't know what it is, and BC, I know that it is 10. So applying the Pythagorean theorem, we have 26 squared is going to be equal to 10 squared plus the length of AB squared. 26 squared is going to be 776, and this is equal to 100 plus the length of AB squared. Subtracting 100, we get 576 is equal to the length of AB squared. Taking the square root of both sides, we get that the square root of 576 is going to be 24, and this is going to be equal to AB. So AB is 24, and that's the same thing as BC, so this is also 24. So AC is the same thing as AB plus BC. Therefore, it is going to be 48. Now for ED or DE, that's just the same thing as AB and BC. So 24.